Okay, so we're going to work on the new packet. This is the 4.6 to 4.7 packet, and this is page 1. And we're going to go over direct variation. Now, direct variation equation the direct variation equation is y equals ax, where a is the constant of variation. So you should be taking notes on this. Now, a direct variation equation is just like y equals mx plus b when b equals 0. So, although we call it y equals ax, a and the slope are always the same when b equals 0. Okay? So, you can think of the direct variation equation as y equals mx plus b when b equals 0. Now, if b equals 0, and it's just like y equals mx plus b, that means a direct variation equation is a linear equation that goes through the origin. And how do I know it goes through the origin? Because if b is 0, then it must go through the origin. So let's think about this. I'm going to draw a few different graphs, and you're going to tell me which ones are direct variation. Okay, so that's my graph, my coordinate plane. So would this be direct variation? And the answer is no, because although it's a straight line, it doesn't go through the origin. Would this be direct variation? Well, this goes through the origin, but it's not a straight line, so this would be no. Now, is this, well, we'll say no because I made it a curve. Is that direct variation? No, because it curves. How about this? That is direct variation because it is a straight line that goes to the origin. That's direct variation. That's direct variation. That's direct variation. Anytime it's a straight line that goes through the origin, it is direct variation. Okay, so let's just review the important points. Y equals, just erase the important points. Okay, y equals ax is a direct variation equation, as is y equals mx plus b when b equals 0. So it's a linear equation that goes through the origin. Now, when it's in the form of y equals ax, a is what we call the constant of variation. It's the same as the slope when b equals 0. Okay. So now, we are going to look at some equations and we're going to try to identify whether they're direct variation or not. And if they are direct variation, we're going to identify the constant of variation. So here's an equation, 4x plus 2y equals 0. Well, to see if it can be in this form, I have to isolate y. So to isolate y, I'm going to subtract 4x from both sides. Then to isolate y further, I'm going to divide both sides by 2. So I end up with y equals negative 2x. So because this equation can be rewritten in the form of y equals ax, because I think we'll all agree that that is in the form of y equals ax, it is direct variation. And the constant of variation is -2. So remember, the constant of variation, sometimes called the constant of proportionality, is the same as the slope when b equals 0. So that was direct variation because b equaled 0, and the constant of variation was -2. Let's look at the next one. Now, the next one, I'm going to add 2x to both sides. And right away, when I add 2x, we see that b equals 3. Well, if b equals 3, then it's not direct variation. So because this equation cannot be written in the form of y equals ax, it is not direct variation. So to figure it out, if it's direct variation, you put it into slope-intercept form, and you want to make sure that b is 0. If b is 0, the slope is the same as a, and we call that the constant of variation. So now, okay, so the next page says direct variation equations are linear equations that always go through the origin. So linear origin, two keywords. Two variables, x and y, show direct variation provided that you can put it in the form of y equals ax. And a is called the constant of variation, and we say y varies directly with x. So whenever you see the words y varies directly with x, you know that that's direct variation. Now, I want you to think about this equation. If y equals ax, and I ask you to solve that for a, you would divide both sides by x. So we find out that a equals y over x. This is very important because if you're ever asked to find the constant of variation, you know the constant of variation is always going to be y over x. Okay, so now let's look at another example. And this says the equation y equals 2x is an example of direct variation, and the constant of variation is 2. The equation y equals 2x plus 5 is not an example of direct variation. So let's compare the two graphs. Notice the one that is direct variation, y equals 2x, where b is 0, it goes through the origin. And the one that was not direct variation, where the b was not 0, here's the origin. The line does not go through it. Okay? Now, we're going to look at some charts of those two graphs. So here, if we write y equals 2x and we let x equal 1, we know y is 2. When x is 2, y is 4. When x is 3, y is 6. So we're going to look at this chart and see, I wonder if without graphing it and just by looking at the chart, we can tell if this is direct variation. Well, when you look at the chart, we want to know if it can be written in the form of y equals ax. And remember, I said to you that if you solve for a, which is a constant, is the same as y over x. So if I look at this chart and I put all of these numbers, this is x, this is y. If I put y over x here, this is 2 over 1, which is 2. If I put y over x here, that's 4 over 2, which is 2. And if I put y over x here, that's 6 over 3, which is 2. So each time a stays the same, a is a constant, and a is 2. So I could tell from the chart that it was direct variation because I put y over x, and if every time y over x gives you the same number, then it's direct variation. So now let's look at this one, which we knew was not direct variation. Here is a chart of this equation. Now look, I'm going to put y over x. This becomes negative 1/2. Okay. Now I'm going to put this one y over x. This becomes negative 3. Here I'm going to put y over x. That's undefined. Here I'm going to put y over x. That's 7 over 1. None of these are constant. So therefore, this chart tells me this is not direct variation. So to sum up, when it's direct variation, it's a straight line through the origin. When it's not direct variation, it does not go through the origin. When you look at the chart of direct variation and you put y over x, A is always the same when you put y over x. When it's not direct variation, when you put y over x, you get a different number each time. Okay, it does not have a constant of variation. So now we're going to look at these charts and we're going to decide, are these direct variation? So when I look at my first chart, I'm going to say, okay, I'm going to put y over x. I'm going to put y over x. And I'm going to put y over x. Now, I'm going to see what this equals. This equals 2. This equals 2. This equals 2. That means this is yes. It's direct variation, and A equals 2. Okay, so now I'm going to do this one. So I'm going to put y over x. That's 4 over 2. Here, y over x is 5 over 4. And here, y over x is 6 over 6. Well, this is 2. This is 1 1/4. This is 1. So this is not direct variation because when I put y over x, I get different numbers. So this is no. Okay, so I want you all to stop the video and you're all going to try, call this number 3, call this number 4. So I want you to determine if you think those charts represent direct variation or not. Stop the video and turn it back on when you are done. Okay, so for number 3, I'm going to put y over x. So the first one is 0 over 3, which is 0. The second one is 3 over 6, which is 1/2. And I can go ahead and stop because obviously they're not the same, but I'll put 6 over 9 just to show that 2 is different. So this is not direct variation, and it's not direct variation because when I put y over x, I don't get the same number. Let's look at this one. If I put y over x here, I get 8/2, which is 4. If I put y over x here, I get 16 over 4, which is 4. And when I put 36 over 9, I get 4. So this is direct variation, and the constant of variation is 4. Okay? Now, let's turn the page. And, okay, we have a different 3 and 4. So I want everyone to do 3 and 4 now. Again, you're going to put y over x, see if it's constant, and you're going to tell me if it's direct variation or not. So stop the video and start it again when you're done. So for number 3, if I put 5 over 2, it does not equal 8 over 4, which does not equal 11 over 6. So this is no. For this one, if I put 6 over 3, I get 2. 12 over 6, I get 2. And 18 over 9, I get 2. So this is, yes, it's direct variation, and the constant of variation is 2. Okay, so now that we know how to find the constant of variation, we're going to learn how to write direct variation equations. So when we write a direct variation equation, we would do it when we see language like given that y varies directly with x, or given it's a direct variation equation. You're going to have to be told, okay, this is a direct variation equation, or given y varies directly with x, write the direct variation equation. So often they'll give you an x value and a y value, and they'll tell you y varies directly with x, write the direct variation equation. So the first thing you do is you say to yourself, I know the direct variation equation is y equals ax. So I know if I solve for a equals y over x. So now I just substitute my y, which is 26, and my x, which is 2, and I get a equals 13. So I solve for a and I find a equals 13, but I'm not done. Now I have to go back and plug in a into my equation. So this direct variation equation is y equals 13x. You cannot stop here because the directions say write a direct variation equation that relates y and x. So unless you have an equation with an x and a y, you know you're not right. Okay, so let's try the next two. All right, there's 4. Okay, so for the first one, again, it says, given that x varies directly with y, write a direct variation equation that relates y to x. So we know we want to write an equation in the form y equals ax. We also know a equals y over x. So first I put y, which is -5, over x, and I find out that a is -1/3. I'm not done. Now I have to plug that back into y equals ax. So the answer is y equals -1/3 x. Now, let's look. You try to do number 2, stop the video, and start it again when you're done. So for number 2, I say a equals y over x. This can be simplified to +2/9. I'm not done. I then have to plug that back in, and that's my direct variation equation. Now, number 3 has an added task. It says here down at the bottom, okay, once you find the direct variation equation, find the value of x when y is 14. So first I have to find my direct variation equation. A equals y over x. A equals 7/3. So y equals 7/3 x. But now it's saying, what is x when y is 14? So I substitute 14 for y. I'm going to multiply both sides by 3 to get rid of the fraction. So that becomes 42 equals 7x. Divide by 7, divide by 7. So x equals 6 when y equals 14. Okay, now I want you all to try number 4 on your own. So again, stop the video, find the direct variation equation, and then find the value of x when y is 49. So I say a equals y over x, which in this case is 14 over 7, which is 2. So I know y equals 2x. If y is 49, and I divide by 2, that means x equals 49 halves. Okay, so we're going to stop the video here.